In level 2, we will be factoring expressions called trinomials that look like this, and our answer will be two binomials. This is the reverse of multiplying two binomials. So in the past, we've multiplied two binomials and we get a trinomial for our answer. Now we're going the other way. We start with the trinomial and the binomial is our answer. So it's just the distributive property backwards. And we're also going to be doing a special case called the sum and difference of squares when you have two perfect square terms. And I'll show you examples of these. But before we do this, a good exercise to just practice kind of the mental math that you need is you're going to need to be able to find two numbers that have that multiply to a certain number, like negative 36, and add to another number, like negative 9. So I want you to think for a minute. Can you think of two numbers that multiply to negative 36 and add to negative 9? Feel free to pause me while you think. Okay, two numbers that multiply to negative 36 and add to negative 9 would be negative 12 and 3. Negative 12 times positive 3 is 36, negative 36. And if I add negative 12 plus 3, we get negative 9. Okay, now feel free to put me on pause and see if you can do the next two. Okay, for 48 and 14, we want two numbers that multiply to 48 and add to 14. Both positive, so this time it's going to be two positive numbers. I would do 6 times 8 is 48, and 6 plus 8 is 14. And for our last two numbers, we need two numbers that multiply to positive 24 but add to negative 11. Two numbers that multiply to a positive and add to a negative are going to have to both be negative. So I'm going to do negative 3 times negative 8 is positive 24, but negative 3 plus negative 8 is negative 11. Okay, now let's look at some actual examples. In level 2, there will never be a number in front of x squared. In level 3, there will be a number in front of x squared, which makes it a little bit harder. Our goal is to factor these into two binomials, so I always start with two sets of parentheses. And my first two spots will always multiply to give me the first term in the trinomial, which is always going to be x squared in level 2. So we're always going to start with an x and an x, because that multiplies to x squared. Then my last two spots need to multiply to the last term in the trinomial. So I need to think of all the numbers I can multiply to get 20. And to get 20, I can do 1 times 20. I can do 2 times 10, or I could do 4 times 5. But to multiply to a positive, I could also have two negatives. So I could also do negative 1 times negative 20. I could do negative 2 times negative 10. And I could do negative 4 times negative 5. And the question is, which of these pairs of numbers will add up to give me my middle term, which in this case is negative 12x. Okay, so which pair would add up to negative 12? That would be negative 2 and negative 10. So minus 2 minus 10. And to check and make sure you're right, multiply your inside terms. I get negative 2x. Multiply your outside terms. I get negative 10x. Negative 2x plus negative 10x does add to negative 12x. So I'm good to go. That's my answer. Okay, let's try the next example. Again, start with two sets of parentheses, and I put x here and x here, and I need two numbers that, for the last spots, that multiply to 16 and add to positive 8. So the factors of 16 are 1 times 16, 2 times 8, or 4 times 4. And since they need to add to positive 8, it is going to be two positive numbers this time. Which of those pairs adds to 16 or to 8? 4 and 4. So I put plus 4 plus 4. And again, to check my answer, I multiply my insides, 4x, multiply my outsides, 4x. Do those add to 8x? Yes, they do. So this is my answer. Okay, the next two are the special case that we call difference of squares. Difference means subtraction, and both terms are perfect squares. So whenever you have subtraction and two perfect squares, it's going to factor into two binomials. And those two binomials are going to be the same, except one is going to have a plus in the middle and one is going to have a minus. And so in our first spot, to get x squared, we still need x and x. And then in our last spot, we need to have the same number. So I have to ask myself, what number times itself gives me 100? I'm actually doing the square root of 100. And the square root of 100 is 10, because 10 times 10 is 100. So those numbers have to be the same. So you have the two binomials that are exactly the same, except one has a plus in the middle, one has a minus in the middle. And that's our answer. And then the reason this works, when I multiply my middle terms, my inside parts, I get 10x. And when I multiply my outside terms, I get negative 10x. And if I add those together, they cancel out or make 0, which is why there was no middle term in this expression. So this is our final answer. Part D is going to be the same thing, also the difference of two perfect squares. So I do my two sets of parentheses. I put x here and x here, and then I need to think of some number times itself that makes 49, and that's 7 times 7. So I put two 7s, one has a plus, one has a minus, and that's it.